In this video, we'll be demonstrating how to prepare a series of dilutions. In this experiment, we're performing dilutions, which are a technique in chemistry that allows you to create solutions of lower concentrations from more concentrated stock solution. Before we start, a dilution simply means reducing the amount of solute per unit volume by adding more solvent, which in this case is water. We also ensured to transfer the original stock solution to another container before inserting the pipette to avoid contamination. We began with a stock solution of copper ions. From this, we prepared 3 new solutions with concentrations ranging between 10-5 and 10-2 molar. To make the first dilution, we used the 25 milliliter volumetric flask, which is designed for high precision measurements. We transferred a small portion of the stock solution into the flask. Quantitative transfer means making sure all of the measured solution is moved from one container to another without any loss, so that our concentrations can remain accurate. Next, we'll slowly add distilled water up to the calibration mark on the neck of the flask. When doing this, it's important to add the last few drops carefully because a reading over the meniscus can mess with the accuracy of the concentration. And any time during this process, if the solution starts to become cloudy, we will add a few drops of aqueous ammonia to help the copper ions stay dissolved. As you can see, the solution remained clear, so we do not have to add ammonia and we can move on to the next step. After mixing, we transferred the finished solution into a clean, dry beaker so that we could reuse the volumetric flask for the next dilution. For the second solution, we took a portion of the first diluted sample and transferred it with a volumetric pipette into a 25 milliliter flask. We also made sure to prime the pipette by wiping the outside dry, then drawing a small amount of the solution that we transferred, tilted and rotated it until all of the walls were coated, discarded, and then rinsed.
It is important to note that in making our dilutions, we used 4 milliliters of the previous dilution sample. Each sample will be more diluted than the last. Here, Maya is using this process in making our next sample. After we obtain our 4 milliliters of our previous solution, we begin adding water. However, we stop when the sample looks too cloudy for our liking.
Once the solution begins to turn cloudy, we stop and add ammonia until it becomes clear.
To make the solution clear again, we add approximately 10 drops of ammonia solution. It becomes clear right away.
We repeat the same process for the third solution. The solution is clear and does not need ammonia. Each dilution is ready to be transferred into the cuvées to be viewed under the spectrophotometer.